Okay, so in this video, we will find the given indefinite integral with the help of a trigonometric substitution, as again it is required. So if you look at the expression here, we have a polynomial, and we have something almost squared minus a constant, and here you should think of secant squared minus 1 is tangent squared, which will cancel the square root in the exponent. So let's take this aside. So we have 9x squared minus 7. And I can write 9x squared as a perfect squared, right? It is simply 3x squared minus 7. And now, if I replace 3x by secant of theta, that's not going to work because I will have then, by squaring, secant squared minus 7, but I need secant squared minus 1 to be able to obtain a tangent squared. Well, if there was a multiple of 7 coming out of the square, I could factor it and things would work out. So what squared will give me 7? Of course, that is the square root of 7. And now we have the proper substitution. We are replacing 3x by root of 7 secant of theta. We need then our differential, so take on both sides a differential. The differential of 3x is simply 3dx. The differential of root of 7 secant is of course root of 7 secant tangent d theta. We need to solve for dx, so divide both sides by 3, and dx is root of 7 over 3 secant tangent d theta. Let us simplify then this expression as we have just said. So if you square 3x, you get 7 secant squared. So we have 7 secant squared minus 7. If you factor a 7, then you have 7 times secant squared minus 1. But secant squared minus 1 is tangent squared. But of course we don't just have 1 over 9x squared minus 7, which is now 7 tangent squared, but we have a power of 3 over 2. So let's replace everything now. So we'll have a root 7 over 3 secant tangent d theta for our dx. I'll put the root 7 over 3 up front as a scalar multiple. Well, still inside the integral for now. So root of 7 over 3 secant tangent d theta over our polynomial to the 3/2 power. So if we distribute, we have 7 to the 3/2. And tangent squared to the 3/2, take the square root, that cancels the power of 2, you're left with tangent, and therefore tangent cubed. Now we can simplify. Now, if you cancel the root of 7 from both terms, this is subtracting 1/2, and 3/2 minus 1/2 is 2 over 2, which is 1. That leaves you with a 1 over 7 times a 1 over 3 is 1 over 21. We can also simplify a little bit. We have secant on top over tangent cubed is of course 1 over tangent squared. And once again, with the proper trigonometric substitution, we have converted the original integral into a trigonometric integral. The question is now, how do we find this given trigonometric integral? Well, everything is in terms of sign of secant and tangent. So as usual, we ask and we factor a secant squared. Well, there's a single secant on top, and even if you did secant over secant, that wouldn't work. I'll let you ask why. Then we could try and factor a secant tangent by multiplying by tangent over tangent, but also would not work. And I'll also let you figure it out. So as both methods with secant and tangent fail, it's natural not to try and convert back to a function of sine and cosine. So secant is 1 over cosine. And now we are dividing by tangent squared. But tangent is sine over cosine. So tangent squared is sine squared over cos squared. But if you divide by sine squared over cos squared, you multiply by the reciprocal, which is cos squared over sine squared. We can of course simplify. So cancelling a cosine will leave us with a cos of theta over a sine squared of theta. D theta. And you should be happy about this, as this is now a simple u substitution. The derivative of sine is cosine, which multiplies the expression, and so we let u be sine of theta. And so you see, after making first a trigonometric substitution, then we must make a second substitution that is now a u substitution, a much simpler type of substitution. So the differential du will be cos of theta d theta. And so the integral becomes 1 over 21, 1 over sine squared, but this is 1 over u squared, and the numerator cos theta d theta is quite simply du. And we can of course integrate 1 over u squared by bringing it back up as a u to the negative 2 and using the power rule. So we have 1 over 21 stays up there, times. We add 1 to the exponent, so negative 2 plus 1 is negative 1, and we divide by the new exponent, negative 1 plus c. Well, let's simplify a little bit. The negative 1 over 21 will put up front, times u to the minus 1, that's 1 over u, plus of course c. And so now we're done with the integration, but we have to go back to a function of the original variable, which in our case is x. Well, that's a two-step problem. As u is a function of theta, let's first go back to a function of theta. So 1 over u is 1 over sine of theta. So we have negative 1 over 21 times 1 over the sine of theta. And so what is sine of theta now in terms of x? Well, we go back to our trigonometric substitution, which was 3x is the root of 7 secant theta. So if you divide both sides by root of 7, you have that secant theta is 3x over the root of 7. So let me write this again here. So secant of theta is 3x over the root of 7. Well, we're both familiar with cosine, so if you think of it, secant is 1 over cosine, so if you invert both sides, then you will get cosine. So invert secant, you get cosine. And of course you have to invert this as well, which will give you root of 7 over 3x. And of course, as the ratio of two sides, the cosine of theta is the adjacent over the hypotenuse. And we cannot construct from this the corresponding right angle triangle. Let me construct it here. So cosine is the adjacent, which is this side, which is root of 7, over the hypotenuse, which is 3x. And again, by Pythagoras' theorem, we can complete our right angle triangle. This squared plus this squared is this squared, and so the height of our triangle is the square root of the hypotenuse squared, which is 9x squared, minus the base squared, which is of course 7. And you see again that we recover the original quadratic polynomial. And now from this, it's easy to find our sine of theta. As a ratio of sides, sine of theta is the opposite over the hypotenuse. So we have the square root of 9x squared minus 7 over 3x. We can replace in our final answer, so negative 1 over 21 times, well, 1 over sine. So you invert this fraction, which of course gives you times 3x over the square root of 9x squared minus 7. Plus c. And we can make one final simplification. 3 over 21 is 1 over 7. And so our final answer is negative x over 7 square root of 9x squared minus 7 plus c. And we're done. And again, what was interesting about this problem is we had to make two substitutions. The first one was a trigonometric substitution, which transformed the original integral into a trigonometric integral. And to find this new integral, we had to make a u substitution, which led us to a fairly simple integral. And then we had to go back to x into two steps first, going back from u to theta. And then that was fairly easy. And to go back from theta to a function of x, we had to go back to the original trigonometric substitution. And so we could complete our triangle and from this obtain our sine of theta. And that's it.